All righty. So we are, whoops, already having problems. There we go. Okay. Lesson 8.6. We are going to be solving the most basic types of trinomial equations. Most basic types of trinomial equations will have a leading coefficient of 1. That's why there's not a letter A in front of this, the first term of the trinomial. So our trinomials are all going to have an x squared or whatever the variable is. It's, it could be a different variable, but it's going to be variable squared, and then there's going to be a coefficient in front of the next term, and there will be a constant to end with. And they're all going to equal 0 because we're zeroing all of our equations now to solve them, right? So, but our leading coefficient is always going to be a 1. And that's the most basic type of trinomial there is. It's the easiest type to factor because there's only one thing that you've got, one little trick that you've got to worry about as you move through. Okay, so we're going to start off by just kind of reviewing what we're headed towards, because we're going to take a trinomial that looks like this, and we're going to factor it out so that it looks like two terms that we would use distributive property to FOIL or to multiply together to create that trinomial, right? So we're going to work our way backwards to make something like this look like something like this. But let's just real quick remember what happens when we FOIL. Okay, so first terms first, x squared. And then we would multiply the outside terms. So that would be plus 2x. And then we would multiply the two inside terms. That would be plus 5x. And then we would multiply the two last terms, which would be plus 10. Now notice, well, I'll get there in just a second. That gives us a term now, that, or an expression that has 4 terms in it, right? We just got done. In fact, the last thing we did on reviewing the homework from last week was to factor by grouping. So if I factor this out now by grouping, I would have an x squared and a plus 2x. What is my common factor there? X. So it would be x times x plus 2. And that means my other term here, I've got to have a what? I've got to have an x plus 2. And what's my common factor with a 5x and a 10? I would have a plus 5. So x plus 5 and x plus 2. If we work that backwards, we've just factored by grouping, right? X plus 5 and x plus 2. The difficulty, the problem is, when I have a trinomial expression like that, we've already done the step where we combine these two middle terms, right? Because if we were foiling that last one, instead of going to work our way backwards, if we were going to FOIL it, we would have combined these two middle terms, and we would have ended up with x squared plus 7x plus 10, right? So the question becomes, how do we factor a trinomial when these two middle terms have already been added together? Because we don't know, we can't now factor by grouping because we've got 3 terms. We have to have 4 terms to factor by grouping, right? So what do I do here to separate those two back out so that I can factor it? That's the problem. You with me? Does that make sense? Okay. Well, here's the deal. I know that in order to factor this trinomial, that I did a step back here where I multiplied my two last terms. When I FOIL, I've got the last terms, right? Oops, that's the I. Put my arrow in the wrong spot. I've got the two last terms that get multiplied. So 5 times 2 gave me this. Does that make sense? Okay, so I know that in order to factor this, I have to have 2 numbers that multiplied to a 12. So what are my options for numbers that multiply to a 12? 112, 2, 6, 3, 4. Okay? The other thing that happened is I had 2 middle terms that when I added them together, I had a 2 plus a 5 to get a 7. So I need 2 terms that multiply to 12 but add to 7. Does that narrow my choices down? It's got to be 3 and 4. Okay, so my expression that I've FOILed to get this trinomial has to be x plus 3 times x plus 4. Has to be. Because watch what happens when I FOIL it. X times x is x squared. Outside terms, x times 4 is plus 4x. 3 times x would be plus 3x. And then 3 times 4 would be plus 12. Combine the two middle terms, so x squared plus 7x plus 12. That takes us right back to the trinomial we started with. Okay? So what I'm looking for when I factor a trinomial, I'm looking for two numbers that multiply to the last term and add to the middle term. That's your rule. Multiply to the last, add to the second. Okay? So let's look at some examples. I need two numbers that multiply to 20 and add to 9. So what are my possibilities for numbers that multiply to 20? 1 and 20, 2 and 10, 4 and 5. Okay, it's perfectly acceptable, by the way, to make this list of factors. If that helps you to visualize these and see the list of factors, awesome. I think you'll get quick enough at seeing what we need to do that you don't need to make the list, but if you need to make the list of factors, it's perfect. So what do I need now? I've got my list of factors that multiply to 20. Which ones add to 9? It's only these two. And guys, there's only ever going to be one possibility. It's not like you're going to list. Now, if we start listing factors backwards, like I could list 5 and 4 backwards, right? Now, oh no, now I've got two possibilities. Well, it's the same two numbers. Okay, you're never going to have two other numbers that give you, like 6 and 3 add to 9, but they don't multiply to 20, right? I mean, you can't come up with the wrong numbers if you do it this way. So that would be x plus 4 and x plus 5. Does it matter if I write those backwards and put x plus 5 and x plus 4? No, it doesn't matter. So this is it. All right, so the next one. I need two numbers that multiply to 24. What's my list of possibilities? 124, 212, 3, 8, 4, 6. And which ones do I want? 3 and 8, because they add to 11. Okay, so that would be d plus 3 and d plus 8. Feeling good so far? Feeling okay with this? All right. So two numbers that multiply to 9 and add to 10. Okay, wait a minute. 1 and 9. If I'm going to make my list of factors, do I need to make any more? Okay, because I just found the one. You can, as you make your list of factors, check each one as you go. So 1 and 9 multiply to 9, add to 10. I don't care how many other factors there are that multiply to 9 because I found the one I'm looking for. There can't be two possible solutions. Okay, so it's going to be n plus 1 and n plus 9. Now with 9, your list of factors is going to be pretty short. The only other possibility was 3 and 3, right? But what if we're doing something like 256? That's going to have a crap ton of factors, right? And so check each one as you go. And don't worry about making an entire list if it's a really big number. Okay? All right, now, what happens if we throw some changes in here? What happens if we have B is negative and C is positive? Now we've got to take some signs into account. Notice that when everything is positive, all of your factors are going to be positive. It has to be that way. But if we start throwing some negative symbols in there, now all of a sudden I'm going to have some negative symbols somewhere because I've got to have negatives in the original terms, correct? Okay. Well, when I multiply two numbers to be 21, and it's a positive 21, both of those numbers could be positive, right? It could be like 3 and 7. But if it's going to be a positive 21, what else could they be? Negative 3 and negative 7 would also be a positive 21, right? When you end up with a negative symbol here, though, Remember, I need two numbers that multiply to positive 21, but they add to negative 22. So what are both of my numbers going to have to be if they add to a negative? They're going to have to both be negatives. So I need a negative 1 and a negative 22, or sorry, 21. And look at there. Those multiply to positive 21, and those two add to negative 22. So I found my two factors. So m minus 1 and m minus 22. No, 21. Doggone it. I got fixated on that 22 there. Okay. So, two numbers that multiply to a positive 12 but add to a negative 8. So both numbers need to be negative. What are my possibilities for numbers that multiply to positive 12? Negative 1, negative 12. Negative 2, negative 6. Oop, don't need to go any further because I found two negative numbers that multiply to 12, and negative 2 plus negative 6 would be negative 8. So it's x minus 2 and x minus 8. Okay? No, doggone it, I'm doing it again. X minus 6. Dang it. All right, two numbers that multiply to positive 28, add to negative 11. Negative 1, negative 28. Negative 2, negative 14. Negative 4, negative 7. There we go. So W minus 4 and W minus 7. All right, feeling okay so far? All right, so we've looked at all positives. We've looked at a positive C and a negative B. What's another possibility here? What if we have a negative C? Now, C can be negative and B be positive, or C can be negative and B be negative. It's just going to kind of depend on how things work out. Because if I want two numbers that multiply to a negative, what has to be true? One has to be positive, one has to be negative, right? The only way you get a negative product if one is negative and one is positive. So now I need my factors of 15, but I don't know which one's positive and which one's negative yet. So what are my factors just of 15? 1 and 15, 3 and 5. Okay, so now I need some combination of those that will multiply to a negative, so one of them has to be negative, but then when they add together, it's going to end up as a positive.
Oh,
Negative 3, positive 5. Since this number is positive, the largest of the two values needs to be positive. So I need a negative 3 and a positive 5. Negative 3 times positive 5 is a negative 15, and a negative 3 plus 5 would be positive 2. That tells me how I need to organize my factors, x minus 3 and x plus 5. Does that make sense? Nathan.
So is it just that the lowest number is always first in the class?
The way I typically write these is that I put them in numerical. I put like negative 3 is a smaller number than plus 5. That's just kind of, it's the way I do it, but it's not the way you have to do it. It's perfectly acceptable to write it as x plus 5 and x minus 3. Okay, there's nothing wrong with that at all. I always put the smallest number first. Just a habit I developed. Okay, so let's look at this one. Two numbers that multiply to 48, but then they're going to, or multiply to negative 48, but they add to positive 13. So what's going to be true about my two factors if it adds to a positive?
Two negatives.
The biggest number of the two factors needs to be a positive number, right? So my factors of 48, there's going to be a bunch of them. 1 and 48. 2 and 24, that's not the one I'm looking for. 3 and 16, that's the one that's going to work, right? 16 minus 3 is 13. So I would have a negative 3 and a positive 16 because I want the bigger number to be positive. Okay, so y minus 3 and y plus 16. Now, what's different about these two? They're all negative, or the last two terms are negative. That means that when I factor this one, the larger of my two factors needs to be negative, right? The largest value needs to be negative. So factors of 18, 1 and 18, 2 and 9. Do I need to go? I don't need to go any further. Okay, that's it. 9 and 2, I can make a 7 out of a 9 and a 2. So I need to have a positive 2 this time and a negative 9. So x minus 9 and x plus 2 are my two factors. All right, so now two numbers that multiply to negative 24, add to negative 2. The largest of the two numbers needs to be negative. So 1 and 24, 2 and 12. What'd you say? 4 and 6. Okay, so 3 and 8, 4 and 6. So if I was just making the list of factors, I would have got all the way to 4 and 6 before I got that. But and if you're seeing it, guys, some of you are just gonna, this is gonna come naturally to you. You're just gonna see the factors and you're not gonna have to make these lists. That's fine. I'm not asking you to make the list. I'm trying to do the same thing every time just to help anybody who might be struggling. So if you see the numbers right off the bat, go for it. Don't worry about making the list of factors. All right, so I need an R minus 6 and an R plus 4. Okay? All right. Now, we're going to solve equations by factoring. We can do the same thing we've been doing the last couple lessons where we're going to set the equation equal to 0. We're going to zero the equation, then we're going to solve the equation. Okay? So how do I zero an equation? Get everything to the same side, get a 0 on one side by itself. So x squared plus 6x minus 27 equals 0. So now I need two numbers that multiply to negative 27 and add to 6. 3 and 9. Okay, so that would be x plus 9. Oops, I did it backwards than I normally do it, but that's okay. X minus 3. 9 times negative 3 would be negative 27, and a positive 9 minus 3 would be a 6. Okay, so those are my two factors. It's equal to 0, so I just take each one of them equal to 0. X plus 9 equals 0. X equals negative 9. And then x minus 3 equals 0. Add 3, so x equals 3. So my solution set, x equals negative 9 and 3. What's up, Lane?
Oh,
Good? Okay. All right, everybody good with that one? I'll leave you time to write it down if you're still working there. Okay. Subtract 70. Subtract 70. Z squared minus 3z equal, minus 70 equals 0. So I could make a long list of factors for numbers that go into 70. There's going to be a few, not terribly many, I guess, but anybody want to jump in with what the right one is? Multiply to 70, add to negative 3.
10 and 7.
Negative 10, positive 7. There we go. So z minus 10, plus 7 equals 0. So z equals positive 10. Everybody okay if I skip some steps because I don't have a lot of room on this page? Okay, and z equals negative 7. Everybody good with that? Okay, so z solution set negative 7 comma 10. Oops. Are you kidding me? Hey, come get your assignment. Do the evens. I didn't know the bell was about to ring. Do the evens on the assignment. Thanks, guys.
Hey, just hand out the whole thing. This is what I
Lula,
sent to you.
Brody Seidel, Olivia
Uh-oh.
Buchanan,
What are
Um,
you doing here?